Hi guys, I hope you're all doing well. Today we're going to talk a little bit about radicals, rational numbers, and irrational numbers. So you might be wondering what all of these terms mean. So rational numbers are numbers that you can write as fractions. These are numbers like 2/5, -2, +2, anything on the left side of the diagram, and that includes numbers in the bubble, which we'll get to later. So rational numbers can be positive, negative, or 0. Irrational numbers are just the opposite. They're numbers that you can't write as fractions. So when you put them in the calculator, they are decimals that don't have repeating digits, and the decimal also doesn't stop. So a very famous one is pi, and also the numbers in the bubble count as well. So irrational numbers can be positive or negative as well. And if we look inside the bubble, which are radicals, these are nth root numbers. So it sounds a little confusing, but it's a lot simpler than it sounds. So these include square roots, cube roots, fourth roots, or any other root, you name it. So square roots, which are probably the most familiar to you, are actually second roots. And cube roots are third roots, and anything else you just call it by the number. So like the sixth root, for example. So this just means that if we have an example like 9 equals the square root of 81, that just means that 9 times 9 equals 81. And you can see that we have two 9s here. Now moving on to the cube root, if we have something like 2 is the cube root of 8, that means that 2 times 2 times 2, which is 3 numbers, because this is the third root, equals 8, and so on. So that's a little bit about radicals and what they are. So radicals can be rational or irrational depending on the numbers. So if we take a look at the square root of 9, that simplifies down to 3, which is a rational number because we can write it as a fraction. But if we have something like the square root of 6 or negative root 6, that would be an irrational number because we can't simplify it into a fraction. And if we put that in a calculator, it would end up as a decimal that doesn't end or repeat. Okay, now let's look at approximating square roots to the nearest whole number. So square roots, like we just discussed, are radicals, and they're the second root. So for example, let's look at the square root of 6. So we want to put on a number line the two whole numbers that we think it'll be closest to. So if we just run through different whole numbers that we think it might be close to, we can look at 2 squared equals 4, and then we know that the square root of 4 equals 2. So we know that the square root of 6 will be a little bit bigger than the square root of 4, so it'll be a little bit bigger than 2. And if we go up to 3, 3 squared equals 9, and 6 is a little bit smaller than 9, so we know that the square root of 6 is going to be a little bit smaller than the square root of 9. So the square root of 6 lies between 2 and 3. So we have 2 squared equals 4, 3 squared equals 9. And we can make another number line down here for the squares of the 2 and 3, which would be 4 and 9. And then we can plot 6, which will be right here. So 6 is 2 numbers away from 4 and 3 numbers away from 9. So we know it's a little bit closer to 4 than it is to 9. So knowing that it's closer to 4 than to 9, we know that the square root of 6 will be a little bit closer to the square root of 4 than it will be to the square root of 9. So we know that the square root of 6 is going to be a little bit closer to 2. We don't know the exact value, but we do know that it's closer to 2 than to 3. So in order to make this more exact, we can approximate this radical to the nearest half. So we want to add another point on our number line, which is 2 1/2. And 2 1/2 squared let's just do this off to the side. We have 2.5 times 2.5, and we can just treat this as 25 times 25 if we move the decimal places out 1 on both. So we have 5 times 5 is 5, and then we want to put the 2 up top. 5 times 2 is 10, plus the 2 that we added on top is 12, and then 2 times 5 is 10, so a 0 over here, and then we can replace this 2 with the 1 from the 10 that we just multiplied, and 2 times 2 is 4, plus the 1 up there is 5. So our number is 625. But since we move these decimal places out, 1 on 2 numbers, we want to move them 2 decimal places back, if that makes sense. So 2.5 times 2.5 equals 6.25. And we can also put this number on our number line. We have 6.25 is really close to 6, which is what we're looking for. So we also know that the square root of 6 is going to be closer to the square root of 6.25 than it is to 4, because if we look at the difference, 6 is 2 numbers away from 4, but 6.25 minus 6 only 0.25. So the square root of 6 is going to be closer to the square root of 6.25, which means that the square root of 6, when approximated, is going to be closer to 2.5 than to 2 if we look at this number line up here. So we can conclude that to the nearest half, root 6 can be approximated to 2.5. Alright, so now that we know how to approximate a square root to the nearest half, we can apply these same concepts to approximate a radical to the nearest half or whole number, whichever you choose. So keeping in mind that radicals are anything to the nth root, I'm just going to pick a lower root, like the cube root, and we can pick a random example as the cube root of 12. So the cube root of 12, we'll just run through some numbers that we think it might be close to again. Let's just start at 2. So 2 cubed would be 8. So the cube root of 8 would be 2. And we can move up to 3. So cube of 3 would be 27. So 12 is between 8 and 27, so we know that the cube root of 12 will lie between 2 and 3. So again, we can put 2 and 3 on the ends of our number line and the squares on a separate number line. Oh, sorry, I meant the cubes. So we'll put 8 here and 27 here. So we know that 12 is closer to 8 than it is to 27, because if we look at the difference between these three numbers, 12 minus 8 is going to be 4, and 27 minus 12 is going to be 15. So since 15 is greater than 4, we know that 12 is going to be closer to 8. So this also means that the cube root of 12 will be closer to the cube root of 8 than it will be to the cube root of 27. So in case speaking didn't really make as much sense and you're more of a visual learner, this is basically what I just said. So based on this, we know that 2 is going to be less than the cube root of 12. But the cube root of 12 is also going to be less than 3. So we know that the cube root of 12 is closer to 8 than it is to 27, so it's going to be closer to 2 than it is to 3. And if we're just approximating to the nearest integer, then we could conclude that the cube root of 3 is closer to 2. But we can move up to the nearest half as well. So just like before, we're going to add 2.5 onto our number line, and then add it on down here as well. Ooh. we want to add the cube of 2.5 on here. And if we look at the difference between 15.625 and 12, it's 3.625, which is less than 4, which is the difference between 8 and 12. So we know that 12 is going to be closer to 2.5 cubed than it is to 8. Which means that the cube root of 12 is going to be closer to 2.5 than it is going to be to 2. And then using this method, you can place square roots on a number line, just like we did over here.